Ever wonder where planets come from? They're born in cosmic nurseries called protoplanetary disks. Now, if that term sounds like a mouthful, don't worry, we're going to break it down. Imagine a young star, a celestial infant, if you will. In its youth, it's surrounded by a disk of dust and gas, much like a cosmic hula hoop. This is what we call a protoplanetary disk. Protoplanetary is a fancy way of saying before planets, and that's precisely what these disks are, the stuff that planets are made of, before they actually become planets. Now, how does this happen? Well, it all starts with a cloud of interstellar gas and dust collapsing under its own gravity. As it collapses, it forms a spinning disk with a baby star at the center. This spinning, swirling disk is our protoplanetary disk. The materials within the disk, the dust and the gas, start colliding and sticking together. These tiny collisions and unions are the first steps in the formation of a planet. Over time, these tiny particles grow, forming pebbles, then boulders, and eventually planetesimals, the building blocks of planets. These planetesimals continue to collide and merge, growing larger and larger until they form protoplanets. And as these protoplanets sweep through the protoplanetary disk, they collect more material, growing in size until they become full-fledged planets. But it's not just about size. These planets also need to clear their orbit, meaning they need to gather or push away all the material in their path around the star. Once a planet has cleared its orbit, it's officially a planet. So protoplanetary disks are not just cosmic hula hoops, they're factories churning out planets, the very worlds that could potentially harbor life. They're the birthplaces of celestial bodies, the cradles of cosmic creation. So in essence, protoplanetary disks are the maternity wards of the universe, where cosmic seeds grow into full-fledged planets. Dust and gas might not seem like much, but in the universe, they're the stuff of life. This might sound strange, but let's dive right into it. Protoplanetary disks, which are essentially huge swirling clouds of dust and gas, are the nurseries where planets are born. These disks form around young stars, and within them the smallest particles of dust and gas begin to collide and stick together. Over time, these tiny clumps gradually grow into larger ones, eventually forming what we call planetesimals. Now you might wonder, how do these tiny particles come together in the first place? Well, that's where gravity comes into play. Gravity, the invisible force that keeps us grounded on Earth, is also responsible for pulling together these particles of dust and gas in the vastness of space. It's a bit like how a magnet attracts small pieces of iron. As these particles come together, they form larger and larger clumps. These clumps continue to attract more particles, growing in size and mass. After a few million years, these clumps become so large and heavy that they can attract even more material with their own gravity. And voila, we have planetesimals, the building blocks of planets. But the role of dust and gas doesn't stop there. These planetesimals continue to collide and merge, forming protoplanets. These protoplanets then sweep up more dust and gas, growing into fully fledged planets. It's a long process that can take millions, if not billions of years. So you see, dust and gas are not just random particles floating around in space. They're the raw materials that make up the planets we see in our night sky. They're the stuff that forms the rocky core of our Earth, the gas giants like Jupiter, and the icy bodies in the outer solar system. They're the ingredients that make up our universe. Just as a pinch of salt can transform a dish, dust and gas in the cosmos can create something as magnificent as a planet. Did you know a star's baby can affect its parent? It's true in the case of protoplanetary disks and their host stars. Just as children can have a profound impact on their parents, so too can the material in a protoplanetary disk influence the star it orbits. We're not just talking about a gentle nudge here and there. This could involve changes in the star's rotation and the manipulation of its magnetic fields. Let's delve a little deeper. Picture a young star spinning rapidly in the heart of a protoplanetary disk. As the disk material spirals inward, drawn by the star's gravity, it carries with it angular momentum. Now, this isn't some mystical force. Angular momentum is simply a measure of the amount of rotation an object has. It's a bit like spinning a basketball on your finger. The more momentum it has, the faster it spins. So, as the disk material spirals inward and falls onto the star, it transfers some of this angular momentum to the star. This can slow down the star's rotation. It's a bit like a figure skater extending their arms during a spin to slow down. But the disk's influence doesn't stop there. It can also interact with the star's magnetic fields. The moving material in the disk can bend and twist these fields, creating a powerful magnetic connection between the star and the disk. This connection can channel material onto the star's poles, leading to hotspots and intense bursts of energy known as stellar flares. These interactions are not just one way, though. The star can also impact the disk, shaping its structure and evolution. It's a cosmic dance, a delicate balance of forces and influences. So, the dance between a star and its disk is a complex two-way street, each influencing the other in profound ways. This intricate relationship shapes the development of both the star and the planets that may one day form from the disk. It's a fascinating insight into the birth and evolution of planetary systems, a testament to the interconnectedness of the universe. Not all protoplanetary disks are created equal. This phrase rings true when we delve into the cosmic playground where new planets are born. Just like snowflakes, no two disks are exactly alike, showcasing an array of sizes, shapes, and compositions. Some disks are colossal, spanning hundreds of astronomical units, while others are more modest in size. They can exhibit a flat, pancake-like structure or adopt a more puffed-up donut appearance. And let's not forget about their composition. Some disks are rich in gases like hydrogen and helium, while others are dense with dust, ice, and rocky materials. These variations are not just cosmetic, they can influence the types of planets that form, the timing of their formation, and their eventual orbits. A disk's size, shape, and composition are like the ingredients in a cosmic recipe, each adding its unique flavor to the final planetary dish. This cosmic diversity is a testament to the endless creativity of the universe. Like all things in life, protoplanetary disks have a beginning and an end. In the grand cosmic ballet, these disks appear like fleeting pirouettes, capturing the limelight for a relatively short span before gracefully exiting the stage. Their lifespan, while brief in astronomical terms, is incredibly significant in the grand scheme of celestial events. Let's start at the very beginning. A protoplanetary disk is born from the material left over after a star forms. This stellar leftover, a mix of gas and dust, starts to orbit the newborn star, forming a flat, rotating disk. Here in this cosmic nursery is where the magic happens, where the raw materials of planets begin to coalesce. As the disk spins, particles within it begin to collide and stick together, forming larger and larger clumps. Over thousands to millions of years, these clumps grow into planetesimals, the building blocks of planets. These planetesimals continue to collide and merge, eventually forming fully fledged planets. However, this process isn't eternal. The disk has a finite amount of material, and as it's used up in planet formation, the disk gradually thins out. Additionally, the central star, now maturing, begins to emit high-energy radiation and solar winds, which can blow away the remaining gas and dust in the disk. The fate of a protoplanetary disk is thus an eventual dispersion. After about 10 million years, give or take a few million, the disk is largely depleted. What remains is a young star system, complete with planets, asteroids, and often a belt of leftover debris. So as we see, the life of a protoplanetary disk is an ephemeral but crucial chapter in the story of a star system. It's the stage where raw cosmic material is transformed into worlds, possibly even worlds like our own. But wait, you might ask, what happens to the disk's material that doesn't form planets? Well, that's a story for another scene. So even in the cosmos, nothing lasts forever, not even the cradles of planets. Planets are not always homebodies. Sometimes they go on a cosmic journey. You see, in the early stages of a star system's life, protoplanetary disks play a crucial role in the migration of planets. These disks are not just flat, static structures. They're dynamic and complex, filled with dust, gas, and burgeoning planetary bodies. As these young planets form and grow, their gravitational influence can create waves or perturbations in the disk. These waves in turn exert a force on the planet, causing it to move or migrate inwards or outwards through the system. This migration process can alter the entire layout of the star system. It's like a cosmic game of musical chairs with planets shifting positions, sometimes dramatically over millions of years. It's a fascinating dance dictated by the very disks that birthed these planets. So planets can be quite the nomads moving house thanks to their birth disks. Some cosmic mysteries are literally gaping at us. As we explore the vast universe, there are few puzzles as intriguing as the gaps in protoplanetary disks. These gaps, voids in the otherwise dense and dusty disks, have sparked the curiosity of astronomers for decades. What could possibly cause these gaps in the swirling, celestial donuts of dust and gas that surround young stars? The answer, surprisingly, might be right under our noses, or rather right under our telescopes. The gaps may not be empty after all, but rather the cradle of unseen planets. Here's how it works. As a planet forms within the disk, it begins to clear its orbit, gathering up dust and gas like a celestial vacuum cleaner. This process, over time, carves out a clear path around the star, creating the gaps we observe. But if that's the case, why don't we see the planets responsible for these gaps? Well, there are a couple of reasons. First, the planets may be too small or too dim to be detected by our current methods. Second, the dust and gas in the disk can obscure our view, making it difficult to spot the gap-creating planets. However, the discovery of these disk gaps has provided valuable clues about the formation and evolution of planetary systems. By studying these gaps, we can infer the presence of planets, their masses, and even their orbital paths. This information is crucial in understanding not just the life cycle of planets, but also the dynamic processes that shape the universe. Despite our best efforts, the mystery of disk gaps is far from being fully solved. But that's the beauty of science, isn't it? Each answer leads to new questions. Each discovery opens up new realms to explore. The gaps within protoplanetary disks are more than just cosmic voids. They are windows into the birth of planets, keys to unlock the secrets of the universe. So even in the seemingly empty gaps, the universe may be hiding its secrets. Let's take a cosmic step back and look at the big picture. We've journeyed through the vast, intricate world of protoplanetary disks, uncovering some of the universe's most captivating secrets. What have we learned? We've seen how these disks are not just celestial accessories, but the very cradles of planet formation. Gas and dust, seemingly insignificant when viewed individually, play leading roles in this cosmic ballet. They coalesce, forming a dense, spinning mass that over time shapes itself into new planets. We've explored how these disks influence their host stars, feeding them material and regulating their growth. We've marveled at the diversity of protoplanetary disks, each one a unique testament to the complexity of the universe. We've learned that these disks are not eternal but have a lifespan, a moment in cosmic time where they shine the brightest before fading away, leaving behind newly formed planetary systems. We've realized the pivotal role these disks play in planet migration, acting as celestial conveyor belts, moving planets closer or farther from their parent stars. And we've probed the enigmatic disk gaps, those silent whispers of possible planet birth or other intriguing phenomena yet to be fully understood. These insights have profound implications for our understanding of the universe. They offer a glimpse into the processes that led to the formation of our own solar system and Earth. They help us appreciate the intricate, interconnected dance of celestial bodies, reminding us of our place in the grand cosmic scheme. They also serve as a launchpad for future research, a springboard for scientists to dive deeper into the mysteries of planet formation and the evolution of star systems. They open up new avenues of inquiry, new questions to explore, and new horizons to conquer. So next time you look up at the night sky, remember the fascinating journey each planet has taken, from a humble dust grain in a protoplanetary disk to the majestic celestial body it is today. As we bring our celestial voyage to a culmination, bear in mind that the cosmos is brimming with enigmas yet to be decoded. Each fresh revelation, each novel understanding draws us one stride nearer to recognizing our role in this magnificent cosmic ballet. However, we need your participation to sustain this research. If this journey through the cosmos fascinated you and you learned something new, we encourage you to be part of our society. Be sure to like this video and share your opinions in the comments section. Don't forget to subscribe to our channel and hit the bell icon to stay updated on our newest ventures into the cosmos. We appreciate the engagement of fellow space aficionados, as it aids us in pushing the limits of comprehension further. Lastly, spread the word about this video among your friends and family. Let's encourage more individuals to accompany us on this cosmic journey. A community, we can decipher the universe's secrets, and who knows, we might chance upon something truly astonishing. Until we meet again, keep gazing at the skies and keep the curiosity alive. The cosmos awaits.